Thanks for this opportunity to contribute to the planning of the IPY. My name is Thomas Haine. I'm a Professor of Oceanography at Earth and Planetary Sciences at Johns Hopkins University, and I'd like to talk to you about what the ocean dynamics in the Arctic might be like in the 2030s. Here's a schematic map showing the circulation in the northern North Atlantic, the Nordic Seas and the Arctic Ocean. It shows the inextricable connection between lower latitudes and the Arctic Ocean. You can see the warm, salty subtropical water flowing into the subpolar North Atlantic, into the Nordic Seas, and then into the Arctic Ocean as what we call Atlantic water. In this region, intense air-sea interaction freshens and cools the Atlantic water and creates two water masses. One is a cooler, slightly fresher version of Atlantic water which flows out at depth into the Nordic Seas and then into the subpolar North Atlantic. And another one is a surface, freezing, fresh polar water which flows out both east and west of Greenland into the subpolar North Atlantic. Now, this horizontal circulation pattern strength is hard to predict for several reasons. The first is that the winds themselves are hard to predict. And even today, we have a hard job understanding how the winds are driving the circulation, let alone predicting what they might be like in a few years. Part of the reason is that the sea ice momentum transfer from the atmosphere to the ocean is difficult to understand, and the sea ice conditions are changing. The basic dynamics are also uncertain and poorly understood. We don't know what balances the wind stress on average. We think eddies are involved, but there's lots of open questions about how that dynamical balance is actually achieved. We think that the circulation in the Nordic Seas will probably be close to a minimum in the 2030s and then strengthen in the second half of the 21st century. But this is superficial and preliminary work and it needs to be confirmed. The overturning circulation strength in the Arctic Ocean is also hard to predict. Again, the basic dynamics are uncertain. We think that in the Nordic Seas, the overturning circulation will be at a minimum in the 2030s and then increase through the second half of the 21st century. But again, this needs to be confirmed with more research. We know much more about past temperature and salinity changes than we do about future circulation changes. We know that the inflows to the Arctic have been warming. We know that there's been Atlantification of the Eurasian basin in the Arctic Ocean, which means the encroachment of Atlantic water into that region at the expense of the polar water. There have been extensive sea ice changes, and we've seen fresh water accumulate, particularly in the Beaufort Jar of the Canadian Basin. Looking forwards, we expect that the warming inflows will continue to warm. We expect that the hydrological cycle will accelerate with more precipitation, a little bit more evaporation, but not so much as to compensate, and increases in runoff. We also think that there will be export events of fresh water that's been building up in the Arctic Ocean, both east and west of Greenland into the subpolar North Atlantic. So looking ahead to 2030, we think that perhaps the circulation in the Arctic Ocean will look a little more similar to the picture on the right than on the left. We think that there will be an enhanced convergence of heat transport into the Arctic Ocean, that the Arctic Ocean will be warmer. We think that there will be a strengthened hydrological cycle with more precipitation and runoff, with less ice, and a fresher Arctic Ocean. And we think that the export of fresh water from the Arctic Ocean to lower latitudes will also increase. The export of fresh water to lower latitudes is particularly interesting because it slows down the Atlantic meridional overturning circulation. So here's another schematic diagram now of the overturning circulation, again showing the inextricable links to lower latitudes. The AMOC, the Atlantic meridional overturning circulation, is flowing in on the left-hand side and then through air-sea interaction is being transformed in the Arctic Ocean. And the polar water at the top on the right-hand side is slowing down the Atlantic meridional overturning circulation because it's a buoyant source of water. The Atlantic water is getting warmer, the polar water is getting fresher and exporting more of it, and so we think that this is going to retard the overturning circulation. The overturning circulation in the Atlantic itself is projected to decline in the 21st century, but we haven't seen it weaken yet. And so we're interested in understanding how the enhanced export of polar water will affect the subpolar North Atlantic and the AMOC itself in the coming years. To summarise, circulation changes in the Arctic Ocean are hard to predict in the next few years for several reasons. We expect that the inflows will continue to warm, that Atlantification will continue, that sea ice will continue to decline, particularly in summer, and that there will be a strengthened hydrological cycle. We also expect that there will be enhanced freshwater export in polar water from the Arctic Ocean to the subpolar North Atlantic. This uncertainty about the controls on the circulation is an opportunity, because as the system changes, we can perhaps understand the controls on the horizontal circulation and the controls on the overturning circulation or on Atlantification. There's also a great opportunity to anticipate and observe Arctic freshwater export events and their impacts on lower latitudes. Particular questions are when and how will the Arctic freshening be detected in the subpolar North Atlantic? It has not been detected yet. And when and how will the Arctic freshening affect the subpolar North Atlantic circulation and maybe the AMOC itself? Thank you.